This video is on lessons 3 and 4 from Unit 5. So lesson 3 is on summation notation. So you should realize that summation, if you look at the first three letters, sum means add. So you're going to be adding a bunch of numbers up to get your final answer. So the summation symbol is this Greek letter, it looks like an E, capital E. Okay, so that's how you would draw it, something like that. There will be a variable involved. It's usually I, but it could be, if you look down at these examples, like this one has a K, this one has a J, but it's usually somewhere, one of the letters around I. At the bottom, so you always start by looking at the bottom down here first. It will tell you which variable you're using, and it will tell you what number to start with. So if it says like I equals 4, that means you're going to start with the number 4 and you're going to plug in 4 first. And your equation will be over here next to the E. So if it was something like I squared, that would mean you're going to plug in 4. So you'll do 4 squared. And then you're going to keep plugging in numbers going up by 1 each time, and you will end at whatever number is up here. So if it was a 10 up here, that would mean you would plug in 4. Then you would plug in 5, then 6, then 7, then 8, then 9, and then 10. And you'd be done. And you're going to get a bunch of numbers, and then you're going to add all of those together. That's why it's called summation. So let's just do a couple examples so you can see what I'm talking about. So this first one, you'll see the symbol for summation. So you're going to add all of your outputs when you plug in the numbers 3 to 5, so that's really only 3, 4, and 5, and you're going to get some outputs and you're going to add them all up. So first, again, I'm going to show a ton of work for this first one, but then I'll probably not show as much work for the next because you guys can do some of these in your head. So first you're going to plug in 3 because that's your starting number, and you're going to end at 5. So first plug in 3, then you're going to add on what you would get with 4 plugged in, then you would add on what you would get with 5 plugged in. So 2 times 3 is 6, 4 times 2 is 8, 2 times 5 is 10. Add them all up. Your final answer is 24. Next one, you are taking, so this time it's K instead of I. You're going from -1 to 3. So that means you got to plug in -1, 0, 1, 2, and 3. And you're squaring each of these numbers. Now, this one I will show my work because you have to be careful. You have to square -1, which means if you forget parentheses around your whatever you're plugging in, you might accidentally get the wrong sign. A lot of kids will tell me that -1 squared is -1, but -1 squared is actually +1, and if you put the parentheses around it, your calculator won't get it wrong. So you're going to plug in from -1. You go up by 1 until you get to this top number. So the next number would be 0, 1, 2, and lastly 3. So -1 squared is 1, 0, 1, 4, and 9. So your final answer for this one would be 15. The next one, you're taking 2 and you're raising it to the J power. Sorry for that. So you're going to start with -2. So you're going to plug in -2 for J first. So that's 2 to the -2. And then you're going to keep going up by 1 until you get to +2. So that would be 2 to the -1, 2 to the 0, 2 to the first, and then 2 to the second. So 2 to the -2, if you recall from last unit, when you have negative exponents, it moves to the bottom to become positive. So that's 1 over 2 squared, which is 4. This is 1 over 2 to the first, which is 2. Anything to the 0 is 1. This is 2, and this is 4. When you add all of those up, you get 7.75, or 7 3/4. The next one, you're taking -1 and you're raising it to whatever number you're plugging in power. So we're going from 1 to 5. So that's -1 to the first, plus -1 to the second, plus -1 to the third, plus negative 1 to the 4th plus negative 1 to the 5th. Now be careful, a lot of kids think that negative 1 to any power is just 1. It is if it's an even exponent, but if it's odd, it's actually negative. Negative 1 to the 1st is negative 1. Negative 1 times negative 1 is positive 1. Negative 1 times negative 1 times negative 1 is negative 1. This is positive 1, and then this turns out to be negative 1 again. When you add all of those up, negative 1 plus 1 is 0, plus negative 1 is negative 1, plus 1 is 0, plus negative 1 is negative 1. All right, next one, we're plugging in 0 to 2. So when I plug in, this one I'm going to start to do in my head. So when I plug in 0, that's 0 plus 1, that's 1. When I plug in 1, that's 2 plus 1, which is 3. And when I plug in 2, that's 5. That is 9. And the last one. So this time you're taking 1 and you're plugging it in for both eyes. So that's 1 plus, I'll write this one out. This one's a little more work. 1 plus 1 plus 1 plus 2 plus 2 plus 1. And we are stopping at 3. So that's 3 times 3 plus 1. So that's 2 times 1 is 2. 3 times 2 is 6. And 4 times 3 is 12 for a total of 20. So there is a quick introduction to summation. Now, this last example, exercise 4, you're actually working backwards. You really have to start to notice patterns, especially with numbers that you see a lot. You need to notice that these numbers are perfect squares and they go in order. You need to notice that this is 3 squared. 16 is 4 squared. 25 is 5 squared. The dot, dot, dot just means that it's going to keep going in that pattern until you end with 10 squared, or 100, which is 10 squared. So therefore, my summation, you get to pick your variable. I'm going to pick x this time. I'm going to start. My first variable I would plug in is 3. The last one I plugged in was 10, and I was squaring all of them. So I'm going to have x squared. The next one's a little tricky. You will notice that you're adding 3 each time that you go from one number to the next. But you got to be careful because we want to start at negative 6. So if I start at negative 6 and I add on 3 times, I'll use I again, some number I want to start at 0. So that way, when I plug in 0 to start with, I'll get negative 6 for my first term. Now, if I plug in 1, then I will get negative 6 plus 3, which is negative 3, which is the second term. And if I plug in 2, we're increasing by 3 each time. If I plug in 2, negative 6 plus 6 is 0. We got to figure out when to stop. So if you keep going, you're going to end up stopping at 7. 3 times 7 is 21 minus 6 is 15, which is my last number. So there's your answer. And the last one, you need to notice that these are all 5 to some exponent. 25 is 5 squared, 5 is 5 to the first, 1 is 5 to the 0, 5 is 5 to the first, 625 is 5 to the fourth. Now, the only difference is the first 2 are fractions. So that means that I'm going to start with a negative number because remember, negative exponents move the number to the bottom of your fraction, or if it was on the bottom, it would move to the top. So I want to start, that 25 is 5 squared, but I want it to be on the bottom, so I have to start with negative 2, and 625 is 5 to the fourth, so I'm going to end with 4. And that is it for lesson 3. Now we're going on to lesson 4. So lesson 4 is on the definition of a series. So a series is the other half of what this whole unit is on. It does deal with summation, so we are going to be adding. So you will notice that it does involve that symbol as well. So this is the definition of a series. So they use a big S for series, and the subscript is n. It doesn't have to be n. It usually is n, though. You'll see n used a lot in sequences and series. So you're going to take sum sequence denoted by a sub I. You're going to start at 1. The first term, a lot of kids want to start at 0, but that doesn't make any sense. Your first term should be 1. It's got to be a positive integer. And you're going to go until they tell you to stop, n, and you're just going to plug it in and then add them all up. So let's look at this first example. Exercise 2. Consider the arithmetic sequence defined by the first term is 3. To get the last term, wherever you're going to stop, you could stop at 100, you could stop at 7. You're going to do the previous term plus 2. And I knew this was previous because it was n minus 1. So like if I was trying to find the 7th term, I would need 7 minus 1, which is 6. So I'd need the 6th term plus 2. Okay, so the series based on the first 8 terms of this sequence is shown below. So this is what you would get if you plugged in the first 8. So here's the first one, right? This is a sub 1. This would be a sub 2 because 3 plus 2 is 5. Then this would be a sub 3 because 5 plus 2 is 7, and so forth, all the way up till this is the 8th term. What does each of the paired off sums equal? So if you pair them off, if you take the first with the last, and then the second with the second to the last, and the third with the third to the last, and fourth with fourth to the last, you will notice they all sum to 20. 3 plus 17 is 20, 5 plus 15 is 20, and so on. Why does it make sense that this sum is constant? So why are you getting 20 every time you pair those guys off? The first with the last, and then the second with the second to the last. So it should make sense because as one term increases by 2, the other decreases by 2. So as these are going up by 2, these are going down by 2. So it should make sense that as you move to the right and then as you move to the left and you pair them off, you're going to get the same number. How many of these pairs are there? Well, there's 4 pairs. And how many terms were there again? There were 8. So keep that in mind. There are 4 pairs and we had 8 terms. Using your answers to A and C, find the value of the sum. So what would all of these add up to, but using a multiplicative process, so using multiplication? Well, there are 4 pairs, and each pair sums to 20, so 4 times 20 is 80. And if you add all these numbers up in your head or on your calculator, you should get 80 as well. So now we're going to generalize this formula, and you need to know this formula. So if you take So for an arithmetic series, you are going to take the number of terms that they're asking you to use. So in this particular question, they asked us to use 8. You're going to cut it in half because you notice there were 4 pairs, which 4 is half of 8. So you're going to take n, whatever that happens to be, and you're going to cut it in half. So if they asked you to do 100 terms, you would do 50. This number would be 50 here. Then you're going to multiply it by whatever the first term was plus the last term. So you really only need to know the first term and the last term. Because you notice that if you knew that, you could know the second term and the second to last term, but they usually don't tell you the second term. They always tell you the first term. You just might have to find the last term. Okay? And that's it, which is exactly what you did there. So now we're going to do an example using that formula. So part A is a little easier than part B because we know the first term, we know the last term, and they tell us that it was a total of 16 terms. Notice the dot, 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 so we couldn't sit here and count them up because we don't know how many are in this dot, dot, dot. That's why they told us there are 16 terms. So we're missing, they gave us 1, 2, 3, 4, 5. So we're missing 11 numbers in the middle here, but that's okay. We don't care what they are. We only need the first and the last. So to find the arithmetic series, you're going to take the number of terms, which was 16. You're going to cut it in half because there would be 8 pairs. Then you're going to figure out what does the first and the last sum to. which is what the second and the second to the last would sum to. They would all be the same. So this is 40. 16 divided by 2 is 8. So 8 times 40 is 320. So this is kind of like a shortcut. You don't have to sit here and actually add them all up. Okay, now part B is a little harder because they did not give us the last term. They gave us the first term. They told us there were 20 terms. So I can start this. I know that there are 20 terms, so I'm going to cut it in half because that's how many pairs there would be. I know the first term is -8, but here's what I don't know. I do not know that last term. I need to find the 20th term. I need to find a sub 20. Well, you learned in maybe 2 lessons ago, there's a formula to do that. The formula was you start with a sub 1, which is -8 in this case. Then you add on whatever the common difference is, which was 6, times 1 less than that term. So it's 19. So you're going to do 19 times 6. That turns out to be 106. So this is your last term. This is your a sub 20, so that goes right here. Now you can just use your calculator. 20 divided by 2 is 10. -8 plus 106 is 98. So 98 times 10 is 980. So that is what the summation would be of that series. Okay, so this one was a little trickier because we had to find the last term, whereas over here we knew the last term. So this you needed. This was from lesson 5.2. If you want to make a note to yourself to look back at that. It is, remember, on your reference sheet, so you don't have to have it memorized, this formula to find a certain term, but you just got to know which one to use. And it was arithmetic because they said common difference. And that is it for lesson